All right, so we continue with section 3.5, but we're going to continue with the second page, which is graphing. Let's start with number 2. So number 2 should be familiar. It's the one we just looked at on part 1, where we found where does the graph cross the horizontal or slant asymptote. Okay, so how should we graph these? And of course, we're not going to get exact graphs here. We'll double check with the Desmos once we're in class. Here, we're going to give ourselves a sketch, and then we'll double check in class. All right. So we analyze A through E. Let's check out what A through E are. The ones we saw back here. Find the horizontal or slant asymptotes, vertical asymptotes, x-intercept, y-intercept, and then check to see if it crosses the asymptotes. Okay. So let's check to see what does this have. So because the degree of the top is smaller than the degree of the bottom, so the horizontal asymptotes are y equals 0. Right? Let me factor this. So this is x minus 3 times x plus 2. Okay. And then the vertical asymptotes, and this just makes it easier to find the vertical asymptotes. So the zeros are x equals 3 and x equals negative 2, and that actually gives us the vertical asymptotes. X equals 3 and x equals negative 2. Okay, so I'm gonna plot those. I'm gonna go ahead and plot the horizontal and vertical asymptotes. So vertical asymptotes are at x equals 3 and negative 2. Okay, so and then we'll see what happens around those asymptotes. All right, and y equals 0 is a horizontal asymptote. Okay, we want to find x-intercepts and y-intercepts. So the x-intercept is the zeros of the top, as long as they don't coincide with the bottom, and they don't. So x equals 2 should be a horizontal x-intercept. I'm sorry. That's the point 2, 0, right? And then y-intercepts are f of 0. So we plug in 0. 0 minus 2 would be negative 2 over 0 minus 3 times 0. That's negative 3 times 2 if we plug in zeros. So we have negative 2 over negative 6, which will be 1/3. Okay, and that actually gives us a couple of points on the graph already that are actually points on the graph. So those won't be... so at x equals 2, that point is on the graph. And at y equals 1/3, that point is on the graph. Okay, so we know the graph goes through there. Okay, what happens over on this side? Well, that's where we do the as x approaches thing like we did for this one. And we're going to analyze it the same way we did that one. So where do I want to work around? Well, around the vertical asymptotes. As x approaches 2 from the left, like negative 2.0001, what's that giving me? So negative 2.001, if I plug it into the x values here, it'll give me really close to negative 4 on top. It'll give me negative 2 plus 2 would be 0.00001. So that's going to govern what happens. Notice it's a negative number because this is negative 2.001. So this will be a negative number times a negative number will be positive. Negative divided by this positive will be negative. But because this number is getting smaller and smaller, the x plus 2, like negative 2.00000000001, right, will just give us 0.0000001 times the bottom, and then this divided by this very small number will make us drop this way, right? So our graph is actually dropping this way, kind of like 1 over x. And the same thing's happening up here. It's not going to be able to cross the horizontal asymptote, okay, because it only crosses over here. All right, what's happening on this side? Well, on this side, you'd have like negative 1.99999999999 forever. So negative 1.9999999 forever will make this a very a positive, very small number. So you'll have and this will still be really close to negative 4. So you'll have negative divided by negative times positive. That'll give us a positive. But because this number makes everything so small on bottom, this guy's curving upwards this way. Okay, it's going to come down, but it's got to cross over here. So I'm going to say that it curves. right there somewhere, right? Maybe not through exactly that point, right? But I'm just making a sketch. It's got to go over here also. So I'm going to say it reaches up to there, the x-intercept. So it just crossed the y-intercept and the x-intercept. And then once it crosses, what happens, right? Where does it go? I'm going to think that it goes down, follows downward, a downward path. But let's check. So as x approaches 3 from the left, like 2.999999999 forever, the same way. So 2.9 minus 2 will make the top close to 1 all the time, right? Doesn't matter how many 9s we have. On bottom, 2.9 minus 3, that makes that a negative. X minus 3 a negative, but x plus 2 a positive. So you have a positive over negative times positive, and the x minus 3 is a very small number, so that's making the denominator tiny, tiny, tiny. So you have a number over a tiny number, but the bottom number is a negative number. So you're going downwards in the negative direction because you only have one negative out of the 3 factors, top and bottom. Okay, what's happening at 3.000001 as x approaches 3 from the right? 3.000001. So 3.000000, a million zeros would be 3 minus 3 would be 0.000, right? And then times a positive, and a positive divided by that would be positive, so it's going upward. And then I'm gonna guess that it can't cross the horizontal asymptote, so it must go that way. Okay? Let's start on another one. I'm going to start on this one, and we're just going to leave it started for you guys. Okay, so this one, first I want to factor. This is f of x equals 2x minus 2 over x squared minus 1. So the 2x minus 2 on top factors as 2 times x minus 1. The x squared minus 1 factors as x plus 1 times x minus 1. And so you'll notice x minus 1 on top and x minus 1 on bottom would cancel out. Now we don't want to cancel. We do want to say x cannot be plus or minus 1, right? But only the x plus 1 will give us a vertical asymptote. What will happen at x equals 1? Well, it's undefined, so something's got to give there. All right. And so you have one vertical asymptote. Horizontal asymptotes, well, the zeros of the top, as long as there's not the same as the bottom, so there are no zeros on top. So there is no horizontal, I'm sorry, there is no, is it x-intercept? No, horizontal asymptotes. No, I'm sorry, horizontal asymptotes. Yeah, there is no horizontal asymptote. So there's a vertical asymptote, there's no horizontal asymptote. So I'm gonna leave it there. Okay, leave that one there. Let me go on to number 3. F of x equals x to the third over x squared minus 4. And that one also will start together. So number 4 should be a little bit more direct. X squared, f of x equals x squared minus 1 over x squared minus 4. But number 3, it's a little bit different. So this one will have a slant asymptote. Yeah, that we're gonna get by dividing x to the third divided by x squared minus 4. Let's factor this anyway, though. So we can factor x squared minus 4 as x plus 2 times x minus 2. And so that means we have 2 vertical asymptotes. Okay. One horizontal asymptote at y equals, no horizontal asymptote, sorry. No horizontal asymptote because the top is greater. So what about the slant asymptotes? Well, we have to divide x to the third divided by x squared minus 4. And so to do that, I'm going to find me a place just to carry out the division. Scratch paper. X to the third divided by x squared, I'm going to say plus 0x minus 4. Okay, so I don't know if y'all remember how to do the division, but this will give us a slant asymptote. And I'm going to leave that to finishing class. Okay, and then we'll see what happens when the graph starts following the slant asymptote. Okay, so I'm going to leave that one there. We do have 2 vertical asymptotes. I'll draw them on the graph here at x equals plus and minus 2. Oh, this for number 3, right? This for number 3. Again, it's f of x equals x to the third over x squared minus 4. So there's my my vertical asymptotes, and then we'll have to wait to see where we put the slant asymptotes. Okay, so x-intercept, horizontal asymptotes, so there are none. Vertical asymptotes, oh, but there's a slant, right? So slant, we'll have to figure that out. You guys are going to figure that out. All right, vertical asymptotes, x equals 2 and x equals minus 2. Those have been graphed on there. All right, x-intercept. Yeah, x-intercept, and that is zeros of the numerator that are not also zeros of the denominator. So x equals 0, right? Because x to the third equals 0 would be x equals 0. Y-intercepts would be f of 0. So 0 over 0 minus 4 would be 0. Okay, well, I don't know if that helps. Well, we do have one point, though. At 0, 0, there's a point. Okay, and then where does this cross the horizontal asymptote? Or the slant asymptote. Oh, first we have to find the slant asymptote. So we're going to set x to the third over x squared minus 4 equal to the slant asymptote once we find it, and then we'll have to see what happens after that. Okay, so that'll be something that we finish in class. And let's check to see some of the limits as x approaches, let's say, -2 from the left hand side, like -2.00000001, right? So that'll be on top -2.0001 cubed. On bottom, it's going to be -2.001 plus 2 would be negative the 0.001, and -2 minus, that'll be a negative. So it'll be a negative over negative negative. That means our graph should be going down this way. As x approaches -2 from the left, should be heading downwards. Yeah. As x approaches -2 from the right, like -1.999999999. Okay. So I'm gonna let you guys think about those, and then we'll plot it once we get to class. Okay, we'll finish plotting these, and we'll check them on Desmos. Okay, all right. So I'm going to stop it there, and you think about the number 4. If we don't get a chance to do that one, that's fine. But we want to do number 1 and number 3 for sure once we're in class. Okay, I'm going to stop here.